Now today in this video I am going to do questions of progressive view chapter number 28. It's clear. This is the chapter number 28. We will do the, you can see here, this is chapter number 28, progressive view. So today we will do the numericals of this chapter. But before moving over this, we will revise its formulae. What are the formulae of the progressive view? So see here. Equation of the plane progressive view. Equation of the plane progressive view traveling along the positive x direction. So equation of plane progressive view means it is the displacement equation of the particle situated at x equals to x at time t equals to t. For example, here if you see, this is a rope of length L which is fixed to the hook. So this leftmost end we will take the position x equals to 0, while this end will be x equals to L. This midpoint we can take x equals to L by 2. We will take L by 2. Here you can see this midpoint is x equals to L by 2. So see here, what is the displacement equation of any general particle which is situated at x equals to x at time t equals to t? Means the particle, suppose here, its distance from here is x. So this will be the particle at x equals to x. What will be its displacement at time t equals to t? As you know that when a plane progressive wave travels through any medium, for example here medium is rope, when this is traveling through the rope, then what will be the displacement of any particle of the rope at time t? Here it is describing what type of motion. You can see here this particle will go firstly in upward direction, then returns from upward, comes to the mean position, then goes in the opposite direction, and then this. Means it is executing SHM. All the particles of medium are executing SHM. So see here, what will be if the wave is traveling in positive x direction. Here wave is traveling in this direction, so this is the positive x direction. What will be the equation? So you can see what will be the equation here. So first form of the equation is y equals to 2 pi by lambda into delta a sine 2 pi by lambda into bt minus x. A is what? It is the maximum displacement, that is amplitude. yxt means displacement of the particle situated at the x equals to x at time t equals to t. What will be the displacement of this particle at the time t? It is given by a sine 2 pi by lambda into vt minus x. A is amplitude, lambda is wavelength, v is velocity of wave. Velocity of wave, it remains constant. Velocity of particle is variable because the particle is executing SHM. But the wave is traveling along the rope, it will travel with the constant velocity, and it depends upon what? It depends upon the elasticity and density of the medium. Here medium is this rope. So this is the first equation. You can see here what is the first equation. Y equals to a sine 2 pi by lambda into vt minus x. Now there is another form. You can see here y equals to a sine 2 pi, within bracket you can write t by t minus x by lambda. What is capital T? It is the periodic time of SHM. It is the periodic time of SHM, or you can say it is the time in which wave passes through, one wave passes through any point. It is the time in which one wave passes through any point. Then third form is y equals to a sine omega t minus kx. What is k? K is called the propagation constant. Its value is 2 pi by lambda, omega upon v. What will be its unit? Its unit is per meter. So this is the displacement equation. Then you can see here phase difference between the phase of a particle at a time interval delta t. As you know that since the particle is executing SHM, from here it goes to up, then it returns to the mean position, and then once again it returns to the this. So at the different timing it is at different positions. At time t equals to 0 it is here. At time t equals to t by 4, particle is here. At time t equals to 2 into t by 4, it is once again at the mean position. Then at time t equals to 3t by 4, it is maximum displacement in opposite direction. And then once again here at time t equals to 4t upon 4, it is at the mean position. So it is having different phases at the different time. So we will find out the phase difference between the two phases of a particle at the time interval delta t. So here delta phi equals to 2 pi by t into delta t. Here I have written a particle repeat its phase after time t. Similarly, phase difference between phases of two particles at the same time. Phases of two particles at the same time. You can see here one particle may be maximum displacement when the wave travels in any medium, then shape of the medium at any instant will be this. It's clear. This is the mean position. So this particle is at mean position. This is at the maximum displaced position in upward direction. This is at the maximum displaced position in downward direction. So different particles will have different phases at the same time. Different particles will have different phases at the same time. So two particles which are separated by delta x distance, what will be their phases? Phases will be this. Phase difference will be this. Delta phi equals to 2 pi by lambda into delta x. We already know the particles which are lambda distance apart, they will be in the same phase. Those which are lambda by 2 distance apart will be in opposite phases. Now we will do the numerical. One more thing. If the wave is traveling in the negative x direction, instead of positive x, it is traveling in negative x direction, then here in place of minus sign there will be plus. In place of minus sign there will be plus sign. So now you can see here, see the numericals. Here question number 1, but before doing this I will do these numericals which are based on the equation. You can see, for example, this question number 9. Equation of a plane progressive wave is this, where distances are in meter. Distances are meter means y is in meter as well as x is in meter, and time t is in second. Find the speed and direction of propagation of wave. So direction of propagation of wave, it will be positive x direction. Why it is positive x direction? You can see here there is minus sign. There is minus sign. Now you have to find the speed. So see here, how will you find the speed? So I am doing here, you can see what is the equation here. Equation is y equals to 0.05 sin 1000 t minus 4x, and we have to find the speed. Speed of the wave means wave velocity, we have to find v. So on comparing with the standard equation, so when you will compare with the standard equation, what is the standard equation? A sin t by capital T minus x by lambda. So here you rearrange the term, you write in the same pattern 0.05 sin. This you can write t divided by 1 upon 1000 minus x divided by 1 upon 4. When you will compare, what will you get? In place of t, you can get this second. In place of lambda, you will get this 1 by 4 meter. So see here, capital T is 1 upon 1000 second. Lambda equals to 1 by 4 meter. It is clear. So capital T you have determined. So what will be F? F equal to 1 upon T, that is equal to 1000 per second, or you can say 1000 hertz. So what is wave velocity? Wave velocity will be v equals to f into lambda. F is 1000 and lambda is 1 upon 4. So this will be 250 meter per second. 250 meter per second. So now we will see the next question. Now see here. Here you can see this question. Equation of plane progressive wave is this. It's clear. Where distances are in meter and time is second. Find the velocity of wave and direction of propagation. So direction of propagation will be the negative x direction. Why it is negative x direction? Because there is minus in between. Now you compare. So now I am comparing some other equation. Y equals to a sin omega t plus kx, because it is traveling in negative x direction. So when you will compare, in place of a there is 1.2. So amplitude is 1.2 meter. Then in place of omega it is 3.5. This radian per second. This is the angular speed. And in place of k, it is 0.5 per meter. As we know that, what is the unit of k? It is the per meter, meter minus 1. We have to find v. So you can see here, what is the formula of k? K equals to omega upon v. So what will be v? V equals to omega upon k. Omega is how much? Omega is 3.5 upon 0.5. So when you will simplify, it is 7 meter per second. It is 7 meter per second. So this way you can do. Now we will do one more question over this. You can see here. Now see here. We will do the question number 12. What is question number 12? Equation of the wave propagating along plus x direction is given by this. Y equals to this. Where x and y are in centimeter, t is in second. You have to find the speed of wave means v. Frequency means f. Wavelength means lambda. And maximum velocity of particle means a omega. A omega, age amplitude. So you can see here. Now equation is y equals to, this is question number 12. Y equals to 3 sin 314t minus 3.14x. So you compare with the standard equation. So here I am taking a standard equation, this one. You can take any one. A sin omega t minus kx. So what will be A? A equals to 3 centimeter. Omega equals to 314 per second. And K equals to 3.14 per meter. Now you have to find the speed of wave in string. So see here, first part, as we know that K equals to omega upon V. V is speed. So from here, what will be the formula of V? It will be omega upon K. Omega upon K means 314 upon 3.14. When you will simplify, it will come out 100 centimeter per second, because x and y is given in centimeter. 100 centimeter per second, that is 1 meter per second. Then second, you have to find frequency. Frequency we have to determine. Now omega equals to 2 pi f. But the value of omega is given 314. So now you simplify. 2 into 3.14 into f equals to 314. So when you will simplify, f equals to 314, 2 into 3.14. So this will be equal to 314 into 100. You remove decimal by 2 places, and in numerator you increase 2 zeros. 314. So this and this cancel, that is equal to 50 hertz. It will be equal to 50 hertz. Then you have to find the wavelength, lambda, third part. So already you know that there is one more formula of K. K equals to 2 pi by lambda. 2 pi by lambda. K equals to 2 pi by lambda. We will use this formula. So see here, K equals to 2 pi by lambda. What is the value of K here given? So value of K already you have found here, 3.14. 3.14. So what is lambda? 2 pi divided by 3.14. When you will simplify, 14 upon 3.14. This and this cancel, means 2 centimeter, because everything is given in centimeter. Then maximum velocity. Maximum velocity is A omega. So you can see here it is very simple. A is given 3 centimeter. Omega is given 314. Omega is given 314. So you can see here, this is 3 into 314. That is 942 centimeter per second. So in meter per second, 9.42 meter per second. This will be the question. Solution. Now all of you see here. You see the next question. Now we will do question this. Question number 5. Question number 5. Wavelength of a progressive wave in a medium is 0.5, means lambda is given 0.5. There are 2 points at a distance 10 centimeter, means points के बीच की distance 10 centimeter, that is equal to, in meter it will be 0.1 meter. Find the phase difference. So already you know what is the phase difference between two particles which are separated by this distance. So it is 2 pi by lambda into delta x. You substitute the value. 2 pi by lambda is 0.5. Delta x is 0.1. So on removing the decimal, 2 pi upon 5. That is 2 into 180 upon 5. It is 36. 36 to ja 72 degree. This will be the phase difference between two particles separated by this distance. Now see the next question. Similar question like this. Here this is the phase difference between two phases of two different particles. Now see here, there is one more. Question number 4. Wavelength of a wave in a medium is this. Lambda is given 0.45 meter. Phase difference between the two particles vibrating at 2 points due to wave propagation is this, means delta phi is given this. Find the minimum distance between these, means same formula we will use. We have to find delta x, 2 pi by lambda into delta x. Now here in place of, so 2 pi by lambda is this. Delta x is given, phase difference is given pi by 5. So you will get the value of delta x, means except delta x everything is given. So you can find delta x. So this is all about in this video. You can see one more question here. Phase difference two vibrating particles of propagating wave in a medium is this. This is delta phi. Distance between them is delta x is this. You have to find wavelength. So same formula, delta phi equals to 2 pi by lambda into delta x. Except lambda everything is given, you substitute, you will get the answer. So this is all about in this video.